It's about 4 millimeters thick. It's half of a 9 millimeter round for the US viewers. It's because this is what is called in Ukraine, it's a black steel. In the United States it is called carbon steel, not to offend the minority groups of steel, to put the wood in it. And any piece of wood I put into there burns almost instantly, which is quite tragic. We have a hole which is good, and now I have to do something with that hole. But not only that, it is shiny, it looks like a starship. Hello my fellow audience. In case this video is coming out prior to Volkswagen Transporter video, you have probably missed the story about this tank. It's a propane tank. Don't worry, someone has already cut a hole on the side of it. This is basically an empty tank, and what I'm gonna do with it is I'm going to turn it into a portable stove for one of my relatives. So let me start doing this from cutting out a hole in the bottom of it, which will be the top of the stove actually, for this stainless steel piece. It's about 1.5 millimeter thick. This tube is basically gonna be the inner part of the chimney, and also I will attach a couple of steel ribs to this tube, and also I will make a housing. I'll show you this housing later, and probably you will see it on the thumbnail. So let me just start doing this from cutting this hole out. So here we go. This is what it's gonna look like eventually, not mentioning that there will be a system of ribs, and these ribs will help the process of the heat exchange. So the efficiency of this stove will probably be increased by installing these ribs. So anyways, let's just weld this tube to this tank. You can see I am done with welding this tube to this propane tank, and you may probably have a question. This one is 1.5 millimeter thick, this tube, and the propane tank it's about 4 millimeters thick. It's half of a 9 millimeter round for the US viewers. It's because this is what is called in Ukraine, it's a black steel. In the United States it is called carbon steel, not to offend the minority groups of steel. Why is this stainless steel tube thinner than this tank? Because we need significantly higher temperature to melt this stainless steel tube rather than for this carbon steel or black steel. So let me proceed turning this rather diverse portable stove into an actual stove. So the next step will be getting rid of this triangular hole, of this cut also. So let me start doing this. As you can see, I'm done with this hole. And the next step will be cutting out the door to put the wood in it. So once again, let me do some markings and cut it out. I will also show you how to do a latch for such a door, and also I will be welding a hinge on the other side of it. So let me start from the markings. This looks like a very tiny little door, but trust me, it's enough to put your wood inside of it.
Wood.
And also not to let the fire out.
Yeah, fire! Fire! Fire!
Which is for such a stove an important point. So let me weld a hinge to it, later make a wire frame and make a latch so this door will not open on its own. So let's start from the hinge. I have such a hinge and I'm gonna use this in this project. This hinge has come out of the project that has never happened. So let me start welding it to this stove. Also, I have started doing a latch. This latch will serve a purpose of locking this door, and also it will have a handle on it, so you will be able to open the latch and open the door. Then do this in the backwards order. So let me cut out this latch. Basically, this is what the hatch is gonna look like, but it needs a hole here to be able to move like that, and also a handle, so the owner of this beautiful stove will be able to grab this handle and open and close this door. So let's do this. Alright, next step is I'm gonna drill a few holes, one in the latch, second one in this door, and the one of course in the body of this stove. So now we have two holes, and now I'm able to install this latch on its permanent place on this door. One more washer from the back side of the door and a nut, and of course I will weld this bolt to this nut eventually. I have to tighten this bolt and this nut together as tight as possible, because after a little while these joints will be changing their volumes, making the gaps in between of these washers bigger and bigger, and eventually this latch will be moving freely. But now, since it's brand new, I'm gonna tighten it as tight as possible, just enough to be able to move this latch. And afterwards, after this stove will be used for a while, this latch will be easier to open and to close. So basically this is the reason for tightening this nut and this bolt. Right after that I can leave a mark for another pin which will go right here into this cup. And let me just grab another bolt with a couple of washers and a nut to then make a pin out of it. Looks like it's gonna work, so I'm just gonna weld this bolt to this shell. And now that's a latch, but without the handle, so I have to make it. It looks like it's done, but it's not, because we actually need a nut right here on the end of this bolt. But what this nut is gonna hold is a piece of wood which will be the actual handle. The reason for that is when this stove is gonna get real hot, human hand will not be able to grab this bolt. So we need a piece of wood to protect the hands of the end user. So let me make this wooden handle for this stove.
Five minutes later. Many hours later. Tomorrow.
A little bit smoky in my shirt, but I got the charcoal fluid to make a handle for it. Looks like it fits. Just in case you will finish it dry. I just forgot I had a special tool for such occasion. but I'm really glad that such primitive tools do such good results. So let me just install it. So to reinforce the shell I will need to cut some of this rebar or steel wire, whatever we call it, and to weld it across the perimeter of this door opening. Let's do this. Alright, so the door is done. We can open it, we can close it. The frame of the door is done. The whole thing is pretty sturdy. Of course I will have to reinforce it even further. I mean, I will need to connect this weld with this weld and with this weld by welding two pieces of wire right here and right here. What I will have to do is to weld this valve opening. Then I will have to make some wider bottom for this stove, because this one circle, semi-circle, is not enough obviously, and it would be very unsafe to rely on such a small diameter bottom. So I will have to add some legs here, but let me start from the valve hole. I've decided that it would be much easier for me to just cut out the whole thing out of there, together with all the leftovers of the old valve that is stuck in there. So let me turn it upside down and just cut it out. And now I have to do something with that hole. Alright, done with this piece. Let's move on. Well, I'm done with reinforcing this line, and as you can see, we have now several square shapes holding up together this door opening. Also, you cannot see this piece of valve sticking out from the bottom of the stove. So what I'm gonna do is, first thing, I'm gonna cut off this base and later make shorter legs. Of course I need to start from making some measurements. Then I'm gonna take this tube, cut it in 4 pieces and weld these pieces to the tank. So this is how we will end up having legs. Alright, I'm done with the measurements here on the bottom of the stove. So now I'm gonna just cut this tube in 4 pieces and weld these pieces to the spots that I have marked previously. Alright, 4 legs for this stove are done, and now I'm just gonna cut off the old base and weld them 4 legs to make a new base. Alright, I don't know if you can see, but these 3 legs are okay. This one is off right in that direction, so I need to cut off this tack and move it a little bit my way. As you can see, the alignment of the legs seems to be okay. So now I can weld them around, turn it upside down and use these legs as legs finally. So these legs will be the new base. I have shortened the base of this stove in 5 centimeters or 2 inches, and the next step will be cutting out and opening another one for being able to take out all the ashes from the bottom of this tank. So let me cut it out. Alright, we have a hole which is good. The next step will be adding hinges and the latch, so it's the same process as I have done with this door. So we will have another functional door. So let's do this. I have more than 1 hinges from project that has never happened, so let me cut off the unnecessary pieces of metal off of it. It looks ugly, I know, but it was functional. And let me make it functional again. ash door is functional, but let's not forget about the reinforcements. I need to make such a mesh around this opening too, so let's do this. Alright, I'm done with all the reinforcements. We have two functional doors. It looks okay, but I still need to do some handles, and also I will have to make some ribs on this tube. So let me just proceed manufacturing all this stuff. Let me introduce you this shit. I don't need the whole thing, I need only this square tube to cut it in half and make two handles for this stove, so let me do this. Alright, now we have two hands to carry this portable stove around when it's cold, of course. We have two doors, one to insert some wood or anything like wood into it. Let us call it the fuel door. And also the ash door, which will let us get rid of the ashes which will be collecting down here. But as you can see, we can't use it yet because there is no mesh in here yet to put the wood onto. So I have to weld the mesh inside of this stove. So there will be basically two chambers inside this portable stove. The upper one will be for the fuel, for the wood specifically, maybe for coal sometimes, who knows. And the lower one will be for the ashes, and also it will be the air intake. So this will look like that. He will be loading wood inside through this fuel door. The wood will be laying on the mesh, which will be welded around here on this level, and this door will be open for the most time, so the air will be getting inside from this hole, and in case the fire is too big or the stove itself giving too much heat, he will be just able to close this door to stop air from getting inside. It will still be getting in through these tiny little gaps, but it's not a problem. This is the way, I mean, when he will be closing this lower door, there will be less oxygen getting inside, so the fire will lose its power, and the stove will start cooling down in case of such a necessity. I hope you can see this mesh well. These 5 first bars are gonna provide me the leveling of the whole rest of this mesh. So let me just cut several more such pieces, which will go in like that, and I will weld them all that way. So there is the result. I hope you can see it clearly that the mesh is done. It is totally welded to the walls of this tank. But I'm not gonna do a test run of this stove yet because I need to add some ribs to this chimney pipe and also to add a cover over these ribs. So let me do this. The editing magic helps me to very quickly cut out these 16 ribs. This will go like that probably, and all around this tube. So let me just weld them to this tube. Alright, so I'm done with the heat dissipation part. The cover doesn't fit. Okay, I'll fix it a little bit later. Also, I have to weld a ring somewhere around here, so when the extension of this chimney tube sits on this exact chimney tube, it will be supported by the ring and will not sit lower. So I need to weld a stopper ring basically. So let me do this. And of course, the last thing to do is I have to get rid of this flange because it simply is on the way of the smoke and the fumes coming out of this chimney pipe. So I have to cut it around real nice to get rid of this flange, which is smaller diameter than the tube. So the chimney pipe will get wider. Now it's looking much better, and also the fumes will come out freely in a bigger volume than previously. So it's an improvement, trust me. Alright, it's time for a test run. We have made an extension for the chimney pipe and have loaded some firewood in it. And now we're ready to do the test run and to burn off all this paint outdoors.
11 minutes later.
Alright, so my goal was to burn off all the paint of this gas tank, and as you can see, we have heated the tank enough so it starts smoking. The paint is coming off, and I think we're gonna walk away and not breathe in all these fumes, and later we will come back to this stove and I will show you the result.
7 hours later.
I don't know if you can see this on camera, but I have almost got rid of all the paint on this tank. The smoke is coming from the outside. It's the paint burning off of this tank. So we will let it fry for a while and then I will come back and check it. Alright, so you can see the result of burning off the paint. I have also used this wire brush to scrape off the remains of burnt paint. The heat dissipation unit is working pretty well. When the stove was hot, I could barely touch the surface, which means it's working. So if you want to see me doing projects like that, please subscribe to this channel, put the thumbs up, and of course I wish you to have a good day. Cheers! It's been a while since I have captured the last video of me testing out this stove outside at my relatives, and as you can see, I'm wearing my winter suit because winter is coming. And what's the deal? As you can see, I'm sitting in my shop. I'm actively using this stove, but it doesn't belong to me. The thing is, my relative has told me that he won't need it until March, and he has offered me to use it until March, and I said yes, because why not? So I didn't need to make myself another stove for this winter, and this is my temporary setup for this winter. So this is the way probably to finish this video. But before we finish with this video, I would like to tell you that there is a minor change needed for this setup. As you can see, this chimney pipe has no damper, so the airflow is too strong for this setup. So I need to install a damper, but I would not like to proceed using this carbon steel tube, since if I install a damper, for example, right in this place, all the heat would keep on collecting inside this carbon steel tube, and it will probably overheat someday, and some holes may appear on its walls, which is unsafe and very unnecessary, or it will just get deformed, which will make the use of a damper quite not possible. So let me not use this very unsafe carbon steel piece of tube, and for this reason I have bought myself this very shiny, very polished, very beautiful piece of stainless steel chimney pipe. It is slightly longer than this pipe, so I will just need to shorten this brand new pipe just a little bit to make it fit on the place of this carbon steel tube. And also I will slightly improve the heat dissipation via adding ribs to the walls of this stainless steel chimney pipe, which will make, of course, the whole setup more efficient. And adding damper actually is the most crucial part here, since now the wood consumption of this setup is crazy. I think I could not live through this winter like that, because there is not enough wood in the forest for such a setup. And also I would like to explain to you why this airflow inside this chimney pipe is so crazy. It is because you can see only the smaller part of this chimney pipe. The rest of this chimney pipe is outside of my shop, and it is something like 8 feet long. So the airflow inside of this chimney pipe is very strong. In fact, it is so strong that I do not even need to open this lower door to add oxygen to the burning process. As you can see, the chimney pipe together with this strong airflow does its job on its own. This chimney pipe just sucks all the necessary air inside of the stove from these tiny gaps, and any piece of wood I put into there burns almost instantly, which is quite tragic. But not to make a pity party out of this video, let me flex a little bit with this fancy tool on how efficient this heat dissipation device actually is. Let's measure the surface of this stove where the burning is happening. It is 230 degrees Celsius, it's very hot. Let's measure the chimney pipe, for example. It will be 75 degrees Celsius. And also let me try to measure some matte surface of this chimney pipe. It's about 76 degrees Celsius, and let me measure the surface of this heat dissipation device. It is about 54 degrees Celsius. And the last measurement I need is the ribs inside this heat dissipation device. As you can see, the numbers are not exact, and the only explanation of that is that the air getting from underneath, coming through these ribs out, is heating. Well, long story short, it is functional. So I would like to make a similar looking, maybe without the outer casing, heat dissipation device, a heat sink if you will, on this brand new pipe on the outside of it, right below the damper. So let me start doing it. Well, I have finished fabricating this damper valve, and as you can see, it fits perfectly inside of this tube. And also I need to tack weld this central nut to this thread bar, so the thread bar and this valve will become a single piece, and anytime I will be turning this thread bar from the outside, this valve will be opening and closing according to the position of this thread bar. So I had a little bit of a problem. I have accidentally welded this nut to the valve itself, and I had to unscrew this thread bar and clean up this surface. So now I just need to tack weld this thread bar to this nut, and the damper valve is done basically. Also, I will need to make a handle because I want to be able to turn this thread bar with my bare hands, and believe me, this piece will be very hot. And also after that I will need to cut some sheet metal and make the ribs for this chimney pipe, just for a better heat exchange. So let me proceed with customizing this beautiful chimney pipe. Handle does its job, so let's proceed with the ribs. Alright, I have done all these 16 ribs off camera, and now I'm ready to weld them to this wonderful chimney pipe. So let's do this. Alright, my friends, I have finished doing this damper. It is completely functional. It opens, it closes, but not only that, it is shiny, it looks like a starship, and with all these ribs it's gonna be effective at heat dissipation, I believe so. And the only thing what is left to do is to, of course, it's hot, and is to, of course, install it on its position instead of this tube. So So let me do this, and then I will test it out. With this fancy tool, we'll show you some numbers, so please keep on watching. There you go, I have installed this rocket looking thing, and now it is a part of this chimney pipe. And also, unfortunately, it took me several days to do this because I have had a minor eye surgery, because I have got a piece of dust, very nasty one. It was hot, so it has made a hole in my right eye, and this is why in the previous shots in this video you can witness my eyes are totally red, like I'm smoking or something. I actually do not do drugs myself, and I do not advise you kids doing drugs too, because they will totally ruin your life, and trust me, there are more ways to have fun in this life than doing drugs. But let's get back to the topic. So let me show you this thing. I cannot actually touch it because its temperature is actually higher than the temperature of a boiling water. I'll show you the numbers a bit later. First, let me show you how it works. So this is the damper lever. When I put it down like that, the damper is fully open. When I put it up like that, it is fully closed. Let me open it because I don't want any smoke to come into my shop. This has happened previously during the test runs, and I don't want anything like that to happen again. So let's get to the numbers. Alright, as you can see, there is enough heat in the stove, and let's check some numbers. It's 341.42 degrees Celsius on the door. It's about the same on the top of the chamber. Let's check our pipe. It looks like it is 320 or something, and as you can see, the air is moving around our infrared ray, so the numbers are not even because the air keeps on constantly cooling the chimney pipe. Let's try to measure something on the ribs. Looks like it's 70 degrees, but I do not trust these numbers. There is a piece of steel, it's been there for a while. It is 80 degrees Celsius hot. Let's try measuring temperatures on the ribs of the chimney pipe. Looks like it is around 100 degrees Celsius, but let's not trust these numbers again because the air is actually coming out in between of these ribs, cooling down the chimney pipe, so the numbers will never be even in this area. And let me check the damper temperature. So it is about 140 degrees, which is quite possible. And last thing I want to do is to try to measure the temperature on the ribs under the damper. It looks like it is 80 degrees Celsius once again, but let's not trust these numbers, since when I put my hand above these ribs, I can feel hot air coming up in between these ribs and cooling them down. So as you can see, the heat sink, these ribs and these ribs do their function pretty well. Also the damper does its function pretty well. I put the damper into this position when I start the fire, and later I close it just a bit, not fully, but just a bit, so I get a much better fuel efficiency with this pretty hungry stove, and also with such a hungry chimney pipe. So to see more projects like that, and to support my channel, and also to support me in my struggle to help Ukrainian Defense Forces, please subscribe to this channel, put your thumbs up, write something smart in the comments, and maybe donate something if you will. Have a good day.